Section 9.1, solve by completing the square. We're also going to learn how to use the square root property. So when you think about a quadratic equation, when you hear the word quadratic, you need to think of x squared. When you think about x squared, that means you have a quadratic. An equation just means you're going to have an equal sign. We have 4 different ways to solve quadratics. You can factor and then use the zero factor theorem. We could do something called the square root property, if it allows. We can complete the square, and then we're also going to learn how to use the quadratic formula. Now I want you to understand that all 4 ways are possible, but they don't work for every single problem. So you have to be very careful on which one you choose. Don't get so caught up because you might not be able to use that for every problem. You do need to know all 4 ways. So the first way is called the square root property. And the square root property states that if you have some quantity squared equaling a constant, let's say a, then you could take the square root of both sides and you're going to get 2 answers. X equaling the square root of a, or x equals negative square root of a. Thus you could say just x equals plus or minus the square root of a. Now why do we get 2 answers? Because you're putting in the square root. And when you think about it, if you take 3 and square it, you would get 9. If you take negative 3 and square it, you would also get 9. So you're getting 2 answers. So when you are putting in the square root, don't forget to put the plus or the minus to show that you're getting 2 answers. And again, with quadratics, because of the square term, you know there should be 2 answers at the end. So when are we allowed to use the square root property? We can use the square root property when you have a constant just equaling when you have a quantity squared equaling a constant. Now that doesn't always happen, so you got to be very careful that it follows that rule. So looking at this, we have some quantity squared equaling a constant. It does follow the rule, so I'd be able to go ahead and take the square root of both sides. So I'll take the square root of the left, and I'll take the square root of the right, not forgetting plus or minus because I'm putting in the square root. So here the square and the square root just cancel, giving me x plus or minus the square root of 25 is 5. So I really want you to understand you have 2 answers. You have a positive 5 and you have the negative 5. Now the other way to think about it is, what if we just subtracted over the 25 and tried to factor instead? So if I had x squared minus 25 equaling to 0, I could also just factor it. And that would factor into x plus 5 and x minus 5 equaling 0. So then I would set each term equal to 0. And I'm going to get the same 2 answers, x equaling negative 5 and positive 5. So again, you could use the factor theorem, you could do the square root property, and you could possibly use the quadratic formula, which we haven't learned yet. So sometimes factoring still works, sometimes it doesn't. You got to make sure you can do all different ways of factoring and solving quadratic equations by either the square root property, completing the square, or the quadratic formula. So for example, number 2, y squared equaling 5/9. If we try this way, which is the factoring way, it's much more challenging to do. But I do see a quantity squared equaling a constant. So if I have a quantity squared equaling a constant, what can I do? Take the square root of the left and the square root of the right, not forgetting plus or minus. So y is going to equal plus or minus the square root of 5 over the square root of 9. The square root of 9 has a nice square root, which is 3. The square root of 5 will stay as square root of 5. So y is going to equal plus or minus the square root of 5 over just 3 because we took the square root of 9. So looking at number 3, we have x squared plus 8 equals 0. Well, we can't factor that. So factoring way is out. So let's talk about the square root property. If I subtract over the 8, I get x squared equaling negative 8. So it does fall under the category of being able to use the square root property. So I'll take the square root of the left and the square root of the right, not forgetting plus or minus. So x is going to equal plus or minus the square root of negative 8. Well, we have a negative under the radical. From the last sections we learned that that was I, and 8 is 2 times 4, and 4 is 2 times 2. So we have a pair of 2's, and an I is going to come out, and the square root of 2 is left. Don't forget that plus or minus. You have 2 answers. So again, you could write that as 2i square root of 2 Sorry, my pin's messing up. X equaling 2i square root of 2 and negative 2i square root of 2. Two answers. You can keep them together with the plus or minus out in front, or go ahead and separate them. Now with the 9x squared minus 20 equaling 0, I'm going to circle that one for you to try, and I'll give you that the answer is x equaling plus or minus 2 square root of 5 over 3. It's not factorable, so use the square root property. So on number 5, you would have an old way to do this problem, and you would have a new way to do this problem. The old way would be to multiply all that out. Bring over the 1 by subtraction, combine like terms, and try and factor and so forth. But it might not be factorable. So does this follow the square root property? Well, you have some quantity squared equaling a constant. So it does follow that property where we could just take the square root of both sides, not forgetting plus or minus. On the left side, the square and the square root just cancel. On the right side, what's the square root of 1? Well, it's 1. When all of your radicals disappear, you better separate it into two answers and tell me what those answers are. The first answer is when 3y plus 7 will equal positive 1, and the second would be when 3y plus 7 equals a negative 1. So then, how do we continue solving this? We'll subtract the 7. So 3y is going to equal negative 6. And y is going to equal negative 2. On the other one, we'll subtract the 7. So 3y equals negative 8. So y would equal negative 8/3. So you have to continue when all your radicals have disappeared to get to those two final answers. Now looking at number 6, we have 6 minus 7 quantity squared equaling negative 75. The old technique would be to multiply all this out, add over the 75 and continue. But this does follow the square root property. So we're going to take the square root of the left, again plus or minus the square root of the right. On the left hand side, the square and the square root just cancel each other out. Now what about negative square root of 75? Well, I'll let you do the factor tree. With the negative, making it an I, you should end up with 5i radical 3. Now you're not done. You haven't solved for x yet. The next step would be to add the 7, and that's going to go in front of the plus or minus. Those are not like terms, so you cannot put the square root of 3 and all the other stuff with the 7. You just have to put 7 plus or minus 5i square root of 3. And we still got to get x by itself, so we need to divide everything by 6. To be honest, you need to separate them into each its own fraction. So 7 over 6 plus or minus 5i square root of 3 over 6. And then at that point, if you can reduce this, you do so. And if you can reduce this fraction, you do so. But you cannot reduce either one of them, so you are done. Make sure you separate them into each its own fraction. So that's the square root property, which is really nice, but it only works when you have one quantity squared equaling a constant. So the next thing we're going to learn is solve by completing the square. And a lot of students might not like this at first, but it does work out really nicely when the number in front of x squared is a 1. But then we're also going to learn how to do the quadratic formula in the next section. So the first thing you want to do when you complete the square is you're trying to change it into the square root property. So to do so, the first thing you want to do is get to the c over to the other side. Then, if you already have a being 1, you're going to go on to step 3. If a does not equal 1, you need to divide every term by a so that the leading coefficient is 1. Then you're going to take half of the b term and square that number, and then you're going to add it to both sides. Now that's kind of some crazy steps right there, but that'll help you get into a perfect square. So then you can write the left side as a perfect square by factoring. And then you're into the square root property, which is what you just learned. So again, I would pretty much only use this when a is 1, but we're going to show you when a is not 1, some of those examples as well. On MyMathLab, it does ask you to solve by completing the square. I would try it, but if you get stuck, you can use one of the other rules, because I will not pretty much ask you on the test to do a specific way. You do need to know all your ways, but again, I probably will not be specific on which one I want you to do, so you get to choose. So solve by completing the square. We need x squared and x on the same side, with c over on the other side, which is true. We want a to be 1. The number in front of x squared is 1. So we'll go on to step 3. We're going to take half of the b term. So the b term is negative 2. And half of that, so negative 2 divided by 2, is negative 1. So we're going to take half of the b term. And then what are we going to do to it? We're going to square that number. And we're going to add 1 to both sides. So we get x squared minus 2x. I'll leave some space. And we're going to add this 1 to both sides. Now, why do we have to do it to both sides? So we can keep our equation balanced. So why do we do those crazy steps? Because at this point, you should be able to factor that nicely. And that factors into x minus 1 and x minus 1, because that was a perfect square. So we end up with x minus 1 quantity squared, and 8 plus 1 is 9. So we're back to the square root property. We've changed something that was not in the square root property into it by completing the square. So we'll take the square root of the left and the square root of the right, not forgetting plus or minus. So x minus 1 equals plus or minus 3. So like I said, when all your radicals disappear, break it up into the two answers. So we're going to have x minus 1 equaling positive 3, or x minus 1 would equal negative 3. Add over the 1, we get x equaling 4. Add over the 1, we get x equaling negative 2. We have y squared plus 10y plus 22 equals 0. If we want to solve by completing the square, the first thing we need to do is subtract the c over to the other side. So y squared plus 10y equals a negative 22. Then what do? We take our b term, which is 10. We take half of 10, which is 5. We square it, which is 25, and we add 25 to both sides. So take half of your b term and square it, and then add it to both sides. When you do that, the left side should be a perfect square, so you can factor as 5. It always should be the same factor, which is y plus 5 quantity squared. Now on the right hand side, negative 22 plus 25 is 3. So now we have the square root property. We have a quantity squared equaling a constant. So we'll take the square root of the left and the square root of the right, not forgetting plus or minus. So y plus 5 equals plus or minus the square root of 3. We have not solved for y yet. The last thing to do to get y by itself is subtract the 5 and put that in front of the plus or minus. So y is going to equal negative 5 plus or minus the square root of 3. They're not like terms, so you can't continue like you did on number 1. Number 1, all your radicals disappeared, so you were able to put like terms together. Here your radicals stayed, so you're not allowed to put anything together. Now you could separate them into the positive and the negative answer, but that would be about it. So on number 3, I'm going to circle that and give you the answer. I want you to try number 3. The first thing you'd want to do is subtract over the 7. So we're going to have y squared plus 2y, and 9 minus 7 is 2. So I want you to try that one and see what you get. So on number 4, as you can see, the first thing to do is add over the 4. So we get 2x squared minus 10x equals a positive 4. If you look at the rules were that the first number in front needs to be a 1, and it's not. So we need to divide every term by a to get a 1, oops, it should be a minus sign, to get a 1 in front. So we get x squared minus 5x equals 2. Now this is where I probably would not complete the square because, oh my goodness, we're going to have fractions. But let's see how this works. So we take half of the b term. Half of negative 5 is negative 5 halves. So your b term was negative 5, and we take half of it. Then we're going to square that number, which is 25 over 4, and that's what we're going to add to both sides, 25 over 4. So then at that point, you have to factor. Now we've never really factored with a fraction here. So all you got to do is go back to the thing before you squared it, and that's what's going to go in those last blanks. So it'd be x minus 5 halves and x minus 5 halves. It's just this. So just put that in the last blanks. Now on the right hand side, we do have to find a common denominator, which is 4. So this needs to be a 4 and that needs to be a 4. Well, 4 times 1 is 4, so 4 times 2 is 8, and that's going to stay at 25. So again, this is going to be able to be rewritten as x minus 5 quantity squared equaling 25 plus 8 is 33 all over 4. And then what do we need to do? Take the square root of the left and the square root of the right, not forgetting plus or minus. So x minus 5 halves equals plus or minus the square root of 33 all over the square root of 4, which is 2. So the last step is just to bring the 5 halves over. So we're going to add it over. So x is going to equal 5 halves plus or minus the square root of 33 over 2. You try and simplify the square root of 33, but 33 is just 3 times 11, so that can't take anything out, so you're done with that one. So again, ones with fractions are a little bit more challenging, so you might want to not use completing the square and jump to the quadratic formula instead. So what you're going to realize is they're not all going to be factorable. So and they're not factorable when you're left with wonderful square roots. So your factoring is not going to work as much. Alright, last one, number 5. We probably would not choose to complete the square, but we're going to do it this time just so you can work with some fractions. First things first is we need to add the 1 over to the other side. So 5x squared plus 12x equals a positive 1. Since the number in front of 5 is not a 1, in front of the x squared is not a 1, it's a 5, we have to divide everything by 5. Well, that created a fraction. So, what is my b term? My b term is 12 over 5. I have to take half of that. Well, to take half of that, that's just like multiplying the denominator by 2. So we get 12 over 10. That reduces, if 12 over 10 has a 2 in common, 6 over 5, and then we have to square that number and add it to both sides. So I need to add 36 over 25 to both sides, because you got to square this still. Okay? So, a little bit more challenging, but you can do it. So this is going to factor into x plus 6 over 5 and x plus 6 over 5. Where did I get 6 over 5? Remember we talked about it's the thing inside parentheses before you squared it that needs to be put in the blanks. On the right hand side, we need to find a common denominator, which is 25. So this needs to be multiplied by 5, so that becomes a 5, and this is still just a 36. So we do those crazy steps because now this can be written as a perfect square. So x plus 6/5 quantity squared, and 5 plus 36 is 41 over 25. And then we can take the square root of the left and the square root of the right, not forgetting plus or minus. So x plus 6 over 5 equals plus or minus the square root of 41 all over the square root of 25. And the square root of 25 is 5. So the last step, we're going to subtract 6/5, bring it over to the other side. So x is going to equal negative 6 over 5 plus or minus the square root of 41 over 5. If you want to know if you're correct on number 3, send me the answer. Or when we get into the quadratic formula, come back and check it by doing the quadratic formula instead of completing the square.